Hello viewers, welcome to Elimu TV, a place where you watch and learn. I'm your tutor, Alex Musawa, and I'll be taking you through Physics Form 4, our lesson number 39. Our title is Electronics, and we are going to look at energy band theory. What are the objectives of this lesson? To describe what the energy band theory states, and to state the difference between a P and N-type semiconductor. The energy band theory. The atomic structure reveals that electrons revolve around the nucleus in energy levels. In the nucleus, According to the energy band theory, when two or more atoms are brought closer to each other, the energy levels split into smaller energy levels called bands. As you can see, those are bands. This follows from the interaction of both electric and magnetic fields of electrons as they revolve in their energy levels. The outermost energy levels containing valence electrons splits more easily into many bands than the inner levels. The most important band in electronics are the valence and conduction bands, which contain valence and conduction electrons respectively. We have insulators. Under normal conditions, there exists a large energy gap of approximately 3 electron volts between an empty conduction band and a completely filled valence band, as you can see from the figure. Insulators have high resistance to the flow of electric current. A tightly bound electron in a valence band requires large amount of energy to dislodge it from the parent atom and make it cross the forbidden energy gap. You can see the forbidden energy gap from the diagram to find a place in the conduction band. On the other hand, the amount of energy supplied to an electron in a crystal will break down the crystal. That happens when you heat an insulator for a long period of time. What will happen? It will break down. Therefore, temperature increase or addition of impurities to insulators has no effect on their conductivity. Next, we have conductors. And these are substances that conduct electricity. In conductors, the valence and conduction band, as you can see from the diagram, overlap. Therefore, electrons move freely from the partly filled valence band to the conduction band. Many electrons in the conduction band are therefore available freely for electric conduction. The flow of current in conductors is by movement of electrons. A rise in temperature increases the vibration of the atoms, and this interferes with the electron flows. Therefore, the resistance of a conductor increases with temperature. Next, we have semiconductors. Semiconductors. The energy band diagram for a semiconductor. You can see the energy band diagram. The forbidden energy gap is small compared to that of insulators. That's why we say that semiconductors are in between insulators and conductors. The conduction band has almost no electrons, while the valence band is almost completely filled. An increase in temperature increases the chance of an electron moving from the valence band to conduction band. Conductivity is therefore enhanced. Electron conductivities of semiconductors material lie between those of good conductors and insulators. When an electron in the valence band is liberated to cross over to the conduction band, a hole, that is, absence of an electron and regarded positive, is created in the valence band. That is an example of a semiconductor. We have intrinsic and extrinsic semiconductors. And extrinsic semiconductors, we have the N-type and the P-type semiconductors. An intrinsic semiconductor is an extremely pure semiconductor like silicon and germanium. The atoms have 4 electrons in the outermost shell, which combine covalently with electrons from the neighboring atoms to form a crystal. Each atom is thus surrounded by 4 other atoms. Next, we have the p-type semiconductor. The p-type semiconductor. The p-type semiconductor is obtained by doping intrinsic semiconductors with trivalent atoms. And we have the n-type semiconductors. The n-type semiconductor is formed by doping an intrinsic semiconductor with pentavalent atoms like antimony, phosphorus, or arsenic, and they all include an extrinsic. They are all under an extrinsic semiconductor. Therefore, extrinsic semiconductor is made up of the n and the p-type semiconductors. And that is the end of our lesson. I have an assignment for you. Number 1. What is the main difference between n-type semiconductor and the p-type semiconductor? What are the intrinsic and extrinsic semiconductors? Our reference comes from KLB Book 4, 5th edition, 2019, physics book. For more information, you can contact us on our phone number, on YouTube, Elimu TV, on Facebook, Elimu TV, on Twitter at Elimu TV _KE. Thank you for watching Elimu TV. Welcome. Stay tuned.